To limit fault current down to 10,000 amps at a 1600 amp size panel, focus on using an appropriately sized circuit breaker. A fuse is typically not designed to limit fault current to 10,000 amps at this current level. Fuses typically have lower interrupting capacities compared to circuit breakers. The circuit breaker should have a current rating of 1600 amps or higher. Secondly, the circuit breaker's interrupting rating needs to be 10,000 amps symmetrical, rated for class RK-5 or better. NEC code 230.208 requires that overcurrent protective devices, such as circuit breakers or fuses, be sized to limit fault current to a value that the system components can withstand. The code does not specify a specific type of overcurrent protective device, but it requires the use of equipment tested and listed for the intended application. It is crucial to understand the role of interrupting ratings. The interrupting rating of a circuit breaker or fuse is the maximum fault current that the device can safely interrupt without being destroyed or causing an electrical arc. This rating is typically expressed in amps symmetrical. When selecting a circuit breaker or fuse, it is essential to ensure that its interrupting rating is equal to or greater than the available fault current at the point of installation. Available fault current is the maximum current that could flow in a circuit during a short circuit condition. This current is determined by the impedance of the power source, the impedance of the conductors, and the impedance of the equipment connected to the circuit. If the available fault current exceeds the interrupting rating of the circuit breaker or fuse, the device may fail to interrupt the fault current, resulting in a dangerous electrical arc, equipment damage, or even personal injury. Circuit breakers are generally preferred over fuses for applications where high interrupting ratings are required. This is because circuit breakers are designed to interrupt fault currents quickly and reliably, and they can be reset and reused after a fault has been cleared. Fuses, on the other hand, must be replaced after they have interrupted a fault current. There are different types of circuit breakers available, each with its own specific interrupting rating and performance characteristics. Some common types of circuit breakers include molded case circuit breakers, insulated case circuit breakers, and power circuit breakers. Molded case circuit breakers are typically used in low voltage applications such as residential and commercial buildings. Insulated case circuit breakers are used in medium voltage applications such as industrial facilities. Power circuit breakers are used in high voltage applications such as power generation and transmission systems. When selecting a circuit breaker, it is important to consider the following factors. Firstly, the voltage and current rating of the circuit. Secondly, the available fault current at the point of installation. Thirdly, the interrupting rating of the circuit breaker. Fourthly, the type of load being protected. Fifthly, the environmental conditions in which the circuit breaker will be installed. In addition to selecting the correct circuit breaker, it is also important to properly install and maintain it. Circuit breakers should be installed in accordance with the manufacturer's instructions and all applicable electrical codes. They should also be periodically inspected and tested to ensure that they are functioning properly. Proper installation and maintenance of circuit breakers can help to prevent electrical faults and ensure the safety of electrical systems. NEC Article 230 covers services. Part 208 specifically addresses overcurrent protection requirements. It states that each ungrounded service conductor must have overload protection. The overcurrent device must have an ampacity rating not higher than the conductor it protects. There are some exceptions that permit the next highest standard overcurrent device rating if the conductor ampacity does not correspond to a standard rating. Part 208 also requires that the overcurrent protective device be an integral part of the service disconnecting means or be located immediately adjacent to it. This ensures that the service can be quickly and easily disconnected in the event of a fault. The overcurrent device must also be suitable for interrupting the available fault current at its terminals. This is crucial for preventing equipment damage and personal injury in the event of a short circuit. The available fault current can be calculated using a fault current calculator or determined by a qualified electrical engineer. In summary, NEC 230.208 mandates overcurrent protection for service conductors, limiting the ampacity of the protective device to the conductor's rating, requiring it to be integral or adjacent to the service disconnect, and ensuring it can interrupt the available fault current. This ensures the safety and reliability of the electrical service. Consulting with a qualified electrician to assess the specific requirements of the electrical system is necessary. They can accurately calculate fault current levels, determine appropriate overcurrent protection, and ensure compliance with all relevant codes and standards. It is important to prioritize safety and code compliance when dealing with electrical systems. A proper installation and maintenance is crucial for preventing electrical hazards and ensuring the reliable operation of electrical equipment. A qualified electrician has the knowledge, skills, and experience to properly assess the electrical system, select and install the correct overcurrent protection, and ensure that the system is safe and compliant. Remember that working with electricity can be dangerous. Only qualified individuals should perform electrical work. Always energize circuits before working on them and follow all safety precautions. By taking these precautions, you can help to prevent electrical accidents and ensure the safety of yourself and others. The information provided serves as a general educational resource. It is not a substitute for professional electrical advice. The National Electrical Code is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated every 3 years, so it is important to stay up to date on the latest requirements. State and local electrical codes may also apply, so it is important to check with your local authorities. In addition to the NEC, there are other standards and regulations that may apply to electrical installations. These include standards from organizations such as Underwriters Laboratories, the Institute of Electrical and Electronics Engineers, and the National Fire Protection Association. It is important to be aware of all applicable standards and regulations and to comply with them when installing electrical wiring and equipment. Staying informed about the latest developments in electrical technology and safety is also important. This can be done by attending industry conferences, reading trade publications, and taking continuing education courses. By staying informed, you can ensure that you are using the safest and most effective methods for installing and maintaining electrical systems. When working with electricity, always remember to prioritize safety. To energize circuits before working on them, use the proper tools and equipment, and follow all safety precautions. By taking these precautions, you can help to prevent electrical accidents and ensure the safety of yourself and others. The ampacity of a conductor is its current carrying capacity, expressed in amps. The ampacity of a conductor is determined by its size, material, insulation, and the ambient temperature in which it is installed. Conductors with larger cross-sectional areas have higher ampacities. Conductors made of copper have higher ampacities than conductors made of aluminum. Conductors with higher temperature ratings can carry more current than conductors with lower temperature ratings. The ambient temperature also affects the ampacity of a conductor. Conductors installed in hot environments will have lower ampacities than conductors installed in cool environments. The NEC provides tables that list the ampacities of various types of conductors. These tables should be consulted when selecting conductors for electrical installations. The overcurrent protection device should have an ampacity rating not higher than the conductor it protects. This is to prevent the conductor from overheating and causing a fire. There are some exceptions to this rule, but they should be applied carefully and in accordance with the NEC. Grounding is the process of connecting electrical equipment to the earth. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock and prevent equipment damage. Grounding is required for most electrical equipment, including appliances, lighting fixtures, and receptacles. The grounding conductor should be sized according to the NEC. Grounding electrodes are used to connect the grounding system to the earth. Common types of grounding electrodes include ground rods, ground plates, and metal water pipes. Grounding electrodes should be installed in accordance with the NEC. Bonding is the process of connecting different metal parts of an electrical system together. Bonding helps to ensure that all metal parts are at the same voltage potential, which reduces the risk of electric shock. Bonding is required for metal enclosures, metal raceways, and other metal parts of an electrical system. The bonding conductor should be sized according to the NEC. Surge protection devices are used to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other events. Surge protection devices divert the surge current to ground, which protects the equipment from damage. Surge protection devices are available for a variety of applications, including residential, commercial, and industrial. Arc fault circuit interrupters are used to protect against arc faults. Arc faults are a type of electrical fault that can cause fires. Arc fault circuit interrupters detect arc faults and interrupt the circuit, which helps to prevent fires. Arc fault circuit interrupters are required in many new homes and are becoming increasingly common in existing homes. Ground fault circuit interrupters are used to protect against ground faults. Ground faults are a type of electrical fault that can cause electric shock. Ground fault circuit interrupters detect ground faults and interrupt the circuit, which helps to prevent electric shock. Ground fault circuit interrupters are required in many areas where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Electrical safety is a critical consideration in all electrical work. Always to energize circuits before working on them, use the proper tools and equipment, and follow all safety precautions. By taking these precautions, you can help to prevent electrical accidents and ensure the safety of yourself and others. The information presented here is intended for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work or questions. Electrical systems are complex and potentially dangerous. It is essential to have a thorough understanding of electrical principles and safety practices before working on electrical equipment. Electrical codes and standards are constantly evolving, so it is important to stay up to date on the latest requirements. Electrical work should always be performed by qualified individuals who have the necessary training and experience. Ignoring electrical safety precautions can have serious consequences, including electric shock, fire, and even death. Always prioritize safety when working with electricity. Take the time to learn about electrical safety practices and follow them diligently. By doing so, you can help to prevent electrical accidents and ensure the safety of yourself and others. Regularly inspect electrical equipment for signs of damage or wear. Replace damaged or worn components promptly. Keep electrical equipment clean and dry. Protect electrical equipment from moisture and excessive heat. Use the proper extension cords for the application. Do not overload extension cords. Do not run extension cords under rugs or carpets. Do not use damaged extension cords. Be aware of the location of overhead power lines. Maintain a safe distance from overhead power lines. Call before you dig to avoid damaging underground utilities. Never touch a downed power line. Report downed power lines to the utility company immediately. If you see someone who has been electrocuted, do not touch them. Call emergency services immediately. Learn cardiopulmonary resuscitation so that you can provide assistance to someone who has been electrocuted. Consider taking an electrical safety course. Electrical safety courses are offered by many organizations including community colleges, trade schools, and professional organizations. An appropriately sized circuit breaker with a current rating of 1600 amps or higher and an interrupting rating of 10,000 amps symmetrical rated for class RK-5 or better can limit fault current in a 1600 amp panel.